Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet.
What if I told you that two of the most mysterious planets in our solar system just collided? What about the fallout? This was really unexpected. Famous astrophysicist Neil DeGrasse Tyson has just revealed information regarding a cosmic event that may change our understanding of our galaxy. An intergalactic shockwave has focused on Pluto and Neptune, two seemingly faraway celestial worlds. But what does this portend for humanity's knowledge of the cosmos, space travel, and Earth itself? Hold on tight, because this tale is going to astound you. Pluto and Neptune's avoided collision, the fine art of orbital dance. The orbital resonance that keeps Pluto and Neptune from ever colliding is one of the most fascinating parts of their near collision. While their orbits would appear to collide in a disastrous manner, the delicate gravitational connection between the two planets keeps them at a safe distance. The cosmic wonder that is Pluto and Neptune is their natural synchrony, which has captivated scientists for millennia. As a result of their 3-to-2 orbital resonance, Pluto completes 2 solar orbits for every 3 that Neptune makes around the Sun. They are never in the same spot at the same time, despite the fact that their orbits bring them near because of this mathematical harmony. This resonant phenomenon exemplifies the incredible stability that the cosmos can maintain under the control of gravity. But what would happen if that equilibrium was upset? Is it possible that these planets could be pushed out of sync and onto a collision track by outside forces? This delicate balance could be disrupted by even little gravitational disturbances, according to recent observations. A huge asteroid or an undiscovered planet far out in the solar system are 2 examples of extrasolar objects that could affect Pluto and Neptune's orbits. Entering the Kyper Belt by such an object might cause complete disarray in the orbital system. Because of this, some researchers have begun to wonder if the near collision is an indication of a much larger and more terrifying object in the solar system's outer regions. Now we must ask, is the resonance between Neptune and Pluto really steady, or is it more delicate than we believe? From the masses of invisible dark matter to the gravitational pull of faraway stars, there are an infinite number of factors that impact planet orbits. Even a little change in the equilibrium might throw the entire solar system into disarray. If we want to know how the planets will interact in the future, we need to know what this resonance is. Disruption of this delicate balance might have far-reaching and unexpected consequences for worlds beyond Pluto and Neptune. Through the examination of these interactions, astronomers aim to discover more about the laws that control our solar system and the possible threats that exist beyond the planets that are now known to us. The powers that influence the circumference of planets, cosmic shifts. As the near collision between Pluto and Neptune shows, the cosmos is always moving and impacted heavenly bodies by forces that humans can't even begin to fathom. Numerous invisible bodies tug at the orbits of celestial bodies, like planets and moons, as well as faraway stars, disrupting the delicate cosmic equilibrium. However, how did these forces bring Neptune and Pluto so near to a catastrophic collision? Gravity, the universal law that controls the motion of all celestial bodies, is one of the driving factors. When we think about the enormous distances between objects in the outer solar system, the real intricacy of gravitational interactions becomes clear, even though gravity is well understood when applied to stars and planets. Here, even tiny changes in gravity can have huge effects, maybe even changing the paths of whole planets. These cosmic occurrences might be influenced by more than just gravity. Dark matter and dark energy could also be at play. Pluto and Neptune and all the visible stuff in the cosmos are pulled inward by dark matter, which is thought to comprise the vast majority of the universe's mass. Even though dark matter is hard to see and detect, its influence on the motions of the stars allows us to deduce its existence. Investigating the factors that influence planetary orbits requires us to take surrounding stars into account as well. There are billions of stars in our galaxy, each with its own gravitational pull, so our solar system isn't out on its own. Planets like Pluto and Neptune are quite vulnerable to gravitational perturbations, which may cause disastrous events if a neighboring star were to come close to our solar system. Important concerns regarding the stability of the outer boundaries of our solar system have been raised by the near collisions of Pluto and Neptune. Are faraway bodies like Pluto and Neptune being pushed around by forces we don't yet know about? Astronomers are hoping to learn more about these forces and how they influence the universe as they keep studying this event. A realm of icy mysteries, the Kyper Belt. A huge and enigmatic area of space called the Kyper Belt extends beyond Neptune. One of the solar system's least explored regions, this ice expanse is home to dwarf planets, comets, and other heavenly bodies. Pluto and hundreds of additional objects that may provide light on how our solar system came to be live in this icy frontier. When Pluto and Neptune were so close to colliding, how did the Kyper Belt factor in? Numerous objects, from tiny frozen bodies to dwarf planets like Pluto, call the Kyper Belt their home. It is believed that these objects, which are called Kyper Belt objects, KBOs, are leftovers from when the planets were still in the process of formation in the early solar system. That is why they are so instructive. They show us where our solar system came from and what forces molded it. Astronomers have recently found that Neptune's gravitational pull affects the orbits of certain KBOs. Theoretically, the Kyper Belt remains in its present shape due to Neptune's gravitational pull. Pluto and Neptune's recent close call has cast doubt on the arrangement's stability. Would KBOs hurtle toward the inner solar system if Neptune's orbit were to be disturbed, possibly leading to mayhem? The presence of objects in the Kyper Belt that are massive enough to affect Pluto's and Neptune's orbits is another potential explanation. It is speculated by some astronomers that the outer planets may be affected by the gravitational pull of as yet undiscovered planets in the Kyper Belt. The discovery of such a planet would change our knowledge of the solar system and its governing forces in significant ways. To this day, the Kyper Belt is still one of the solar system's most fascinating and baffling regions. The forces that govern our cosmic surroundings and the near collision between Pluto and Neptune may be better understood as we delve further into this frigid frontier. Are rogue planets to blame for their role? A relatively new phenomenon in astronomy is the existence of rogue planets, which are planets that have been expelled from their parent star systems and are now floating aimlessly through interstellar space. Unbound by a star system, these planets wander the cosmos, maybe interacting with other planetary systems along the way. Pluto and Neptune almost collided. May a rogue planet have been involved? I find the idea of renegade planets intriguing and horrifying at the same time. Unless they pass near enough to a star to be lighted, we cannot see these free-floating worlds, which can be anything from tiny rocky objects to gas giants. A rogue planet's gravitational pull may cause Pluto and Neptune to veer off course and possibly collide with one another in a disastrous collision if it were to join our solar system. An errant planet may have once traversed our solar system, producing a cascade of gravitational waves, according to some scientists who think such objects may be more prevalent than previously thought. Pluto and Neptune almost collided. Is this proof of a run-in with an errant planet? There may be some truth to this, but we don't have any proof to back it up just yet. Pluto and Neptune's orbits could have been affected by rogue planets or other objects like comets and asteroids. The trans-Neptunian objects are celestial bodies that are believed to be located in the Oort cloud and the Kuiper Belt. The outer planets may be significantly impacted by their gravitational pull. Our solar system is being shaped by a myriad of factors, and astronomers are constantly on the lookout for rogue planets and other objects that could have had a role in the Pluto-Neptune near collision. Are other, as yet undiscovered, cosmic forces at work, or could a rogue planet hold the key to unraveling this cosmic event? Unseen powers, the gravitational pull of dark matter. Another possible factor, dark matter, emerges as we continue to explore the mystery behind the near collision of Pluto and Neptune. Around 85% of the mass in the universe is thought to be this enigmatic and unseen element. Even though dark matter is invisible to the naked eye, its gravitational pull is quantifiable. Is it possible that the presence of dark matter contributed to the perilous proximity of Pluto and Neptune? Many years of conjecture have gone into trying to determine how dark matter affects our solar system. Even while dark matter mostly interacts with space through gravity, It is pervasive throughout the cosmos, impacting galaxy formation and stellar and planetary motion. For a long time, astronomers have pondered the possibility that Pluto and Neptune, two planets in the outer solar system's Kuiper Belt, may be influenced by dark matter in their orbits. Subtly shifting Pluto and Neptune's orbits, drawing them closer than ever before, could be caused by dark matter's gravitational influence in the outer solar system. The discovery of this possibility has ushered in a new era of research into the potential impact of dark matter concentrations on the stability of the outer planets, which astronomers are eager to explore. To better understand the forces at work in our solar system, additional study into dark matter's function in planetary orbits is highly recommended. The possible involvement of dark matter in this near collision cannot be disregarded, even though our comprehension of its complete scope is currently limited. Is dark matter the unspoken reason for this cosmic occurrence, or is there another theory that needs to be discovered? Astronomers are keeping their fingers crossed that the impacts of dark matter on planetary orbits may lead them to some new insights into the most enigmatic element in the cosmos. If dark matter was involved in the near collision of Pluto and Neptune, it might lead to revolutionary findings that change the way we see the universe and the laws that control it. The potential impact on the entire solar system from the near collision, the ripple effect. Although Pluto and Neptune narrowly avoided a collision, the event may have set in motion a chain reaction with far-reaching consequences for our solar system. Even a small change in the orbit of one planet can have far-reaching effects because of the intricate web of relationships between planetary orbits that scientists are only now starting to unravel. The gravitational dynamics of the outer solar system may have been slightly changed if Pluto and Neptune had nearly collided. Further out in space, this may have an impact on the paths of objects in the Oort cloud and the Kyper Belt. The orbits of planets and other celestial bodies could undergo more substantial modifications in the future as a result of these changes, even though they may not be immediately noticeable. Astronomers are grappling with the pressing question of whether this near collision could trigger a domino effect, causing additional disturbances to the fragile equilibrium of the solar system. Might additional planets be impacted by the gravitational forces between Pluto and Neptune, leading to a possible alteration in their orbits as well? In such a case, how would the solar system evolve over time? In their pursuit of knowledge about the possible far-reaching consequences of this cosmic event, scientists are focusing their attention on these questions. Astronomers seek to foretell planetary motions and detect threats to solar system stability by analyzing gravitational interactions between planets. The fact that Pluto and Neptune were so close to colliding is more proof that our solar system is a living, breathing organism. From the courses of comets to the steadiness of faraway moons, even minute shifts in planetary orbits can have enormous repercussions. We need to be on high alert and ready for anything as we go deeper into the unknowns of the universe. Historical close calls, what we can learn from the past. Celestial bodies have been dangerously close to disaster on multiple occasions, including Pluto-Neptune near collision. Planets, moons, and asteroids have nearly escaped devastating collisions on multiple occasions during the solar system's history. The forces that control planetary orbits and future dangers can be better understood by analyzing these occurrences. When comet Shoemaker-Levy 9 slammed into Jupiter in 1994, it was one of the most well-publicized close calls of the modern era. Even while the comet wasn't heading straight for Earth, it hit Jupiter nonetheless, highlighting the fact that objects in the solar system's outer regions might still represent a threat. Astronomers had a once-in-a-lifetime chance to investigate the aftermath of a big celestial collision when the comet's pieces slammed with Jupiter with enough force to cause explosions that were visible from Earth. In 2004, it was found that the asteroid 99942 Apophis could potentially collide with Earth, leading to another near miss. Even though it turned out that the asteroid would pass Earth by a safe margin, it nevertheless caused a lot of people to worry and made them want to keep an eye out for dangerous asteroids. Astronomers have learned more about the variables that affect planetary orbits and the threats offered by solar system objects by analyzing these past near misses. Such occurrences highlight the fact that the solar system is not a fixed location, but rather a constantly evolving system in which collisions and near collisions can and do occur. Further evidence of the complicated and frequently surprising nature of planetary orbits is provided by the near collision between Pluto and Neptune, which contributes to this expanding body of knowledge. Future near misses and perhaps disastrous collisions can be better prepared for if we keep studying similar incidents. Beyond our solar system's boundaries, the Oort cloud and beyond. Even farther out than the Kyper Belt, which is commonly thought of as the solar system's periphery, is the largely uncharted Oort cloud. Countless frozen bodies and comets inhabit this expansive and enigmatic region, which lies well beyond Neptune's orbit. It is possible that some of these objects had an impact on the close call between Pluto and Neptune. It is thought that the Oort cloud is a spherical shell of ice particles that stretches from around 2,000 to 100,000 AU from the Sun. There have been no direct sightings of the Oort cloud, but its presence is deduced from the behavior of long-period comets, which are believed to originate from this faraway place. The potential impact of the Oort cloud's objects on the trajectories of planets in the outer solar system is a fundamental question about the cloud. The possibility exists that Pluto and Neptune and other planets in our solar system might be in the path of a massive object in the Oort cloud if it were to be disturbed by a star or some other gravitational source. At the very edge of our solar system, when the Sun's gravitational pull is at its weakest, lies the Oort cloud. Stars' gravitational pull starts to dominate in interstellar space, which is beyond the Oort cloud. Is it possible that extrasolar forces are causing objects in the Oort cloud to be perturbed, as shown by the close call between Pluto and Neptune? Researchers in the field of astronomy are keeping an eye on the Oort cloud in the hopes of learning more about the cosmic forces that could have an effect on our solar system. The tense encounter between Pluto and Neptune highlights how little our solar system is in comparison to the vast and intricate cosmos. Planet 9. Is it responsible for the search? A ninth planet, sometimes called Planet 9, has been the subject of much speculation among astronomers in recent years. This made-up world, which is thought to be larger than Earth, might be hiding out in the solar system's outer regions, outside of Neptune's orbit. Could Pluto and Neptune's near collision have been influenced by Planet 9? When scientists in 2016 noted that multiple Kyper Belt objects seemed to be crowded together in a manner that could only be explained by the gravitational effect of a huge, undiscovered planet, the search for Planet 9 began in earnest. Ever since then, scientists have been scouring the entire globe with telescopes, but the enigmatic planet has evaded their detection. Pluto and Neptune are only two of the outer solar system objects that might be significantly impacted by Planet 9's gravitational pull if it exists. Pluto and Neptune are so close to colliding that it has some astronomers wondering if Planet 9 is causing them to break their stable resonance and move closer to each other. Although there has been no concrete proof of Planet 9's existence as of yet, the prospect of its existence has aroused considerable curiosity among scientists. Finding Planet 9 could finally explain why Pluto and Neptune were so close to colliding if it were discovered at some point. Searches for Planet 9 are ongoing because astronomers are interested in learning more about the solar system's outer regions and the forces that control them. Finding Planet 9, regardless of its role in the near collision, would be a huge step forward in unraveling the mysteries of our solar system. Cosmic resonances. Uncovering the solar system's hidden rhythms. The idea of resonance, a form of cosmic rhythm that controls the motions of heavenly bodies, is one of the most intriguing parts of planetary orbits. For instance, Pluto and Neptune are in a special 3:2 resonance, which means that Pluto completes 2 revolutions around the Sun for every 3 that Neptune completes. They are able to avoid collisions despite their orbits crossing paths because of this resonance. However, the stability of this resonance is an important question. Might an outside force have disturbed it, causing these 2 faraway planets to come dangerously close to colliding? There is a fine balance between resonance and other factors that contribute to the stability of planetary orbits. Destabilizing this resonance might cause major changes in planetary orbits if the gravitational forces acting on a planet were to undergo even a little alteration, such as from dark matter, another planet like Planet 9, or even a passing star. Resonance is not limited to the planetary systems of Pluto and Neptune. For billions of years, the resonant orbits of the planets, moons, and asteroids in our solar system have been steady. To keep the solar system from becoming disorganized, these resonances keep the planets in relatively stable orbits. But the consequences can be disastrous if these resonances are interrupted. It is possible that the impending collision of Pluto and Neptune indicates a weakening of the resonance between the two planets. That, if true, may shake the very foundations of our solar system to its very core. Researchers are keeping an eye on Pluto and Neptune's orbits in the hopes of learning more about the factors that control resonance and how to interfere with these unseen rhythms. Resonance also brings up intriguing issues regarding the cosmos as a whole. Are similar resonant patterns governing other planetary systems? And what happens when these patterns are disturbed? If Pluto and Neptune's near collision is any indication, it could be part of a far broader cosmic phenomena. Pluto and Neptune's origins and the difficult dance of their formation in the solar system. We need to travel back in time billions of years to when the solar system first came into being if we want to know how Pluto and Neptune are related. Planets and planetesimals were in a perpetual state of flux in the early solar system, crashing into one another and rearrangement until they found their present orbits. During this chaotic time, when the solar system was still being formed by the gravitational interactions of the planets, Pluto and Neptune probably started their complicated orbital connection. The outer planets of our solar system, including Neptune, Saturn, Jupiter, and Uranus, shifted positions in the early solar system, initially orbiting the Sun closer to it and then further away. Because of the enormous gravitational pull of the planets, smaller things like Pluto were thrown off their orbits during this migration. Pluto and a few other objects ended up in stable but eccentric orbits, while others were thrown out of the solar system altogether. Pluto is thought to have locked into its current 3:2 resonance due in large part to Neptune's motion. To avoid a collision with Pluto, Neptune probably drew the planet into this resonant orbit as it grew farther from the Sun. Pluto and Neptune's recent close call suggests this resonance may not be as solid as it once was. Are we still feeling the effects of the solar system's tumultuous formation? There were a lot more objects in the early solar system than there are now. One of those items was a huge population of planetesimals in what is now the Kyper Belt. These objects probably interacted with Pluto and Neptune as they settled into their orbits, influencing their current positions and dynamics. Pluto and Neptune's impending collision may serve as a poignant reminder that our solar system is dynamic and ever-changing, with planets and smaller bodies exerting subtle but substantial influences on one another. If we want to know when something like Pluto and Neptune's near collision will happen, we need to know how the solar system came to be. Astronomers wish to learn more about the factors that are still shaping planet orbits now by looking at the solar system's early past. Could gravitational waves have had any influence? A fascinating finding in contemporary astronomy is the concept of gravitational waves, which are ripples in space-time brought about by the motion of large objects. It wasn't until 2015 that gravitational waves were directly discovered, despite being predicted by Einstein's theory of general relativity. Black hole mergers and neutron star collisions are two examples of the most extreme phenomena in the cosmos, and scientists have been studying these waves ever since. However, is it possible for gravitational waves to impact solar system planet orbits as well? It may be feasible, according to some researchers. So far, gravitational waves have been caused by cosmic events that are far away, but interactions within our solar system could generate smaller waves. Objects' long-term orbits around the Sun, Moon, and other celestial bodies could be theoretically affected by these waves. The near collision of Pluto and Neptune may have been influenced by gravitational waves. The unusually near proximity of Pluto and Neptune could have resulted from a subtle change in planetary orbits caused by gravitational waves emitted by a faraway cosmic event, like a black hole merger. Even though it's currently just a theory, Studying the potential for gravitational waves to affect planetary orbits is fascinating. To better understand the forces at work in our solar system, researchers are developing new methods to detect and quantify gravitational waves. We would be making tremendous strides in our knowledge of gravitational waves and planetary dynamics if we could determine that they contributed to the near collision between Pluto and Neptune. Although research into gravitational waves is in its early stages, advances in technology may one day allow us to detect more minute and nuanced waves that may have an impact on our solar system. New and surprising ways in which the most powerful forces in the universe interact with the planets and stars may be revealed as we further investigate this new frontier of astrophysics. Are greater powers influencing the cosmos web? We need to take the cosmos as a whole into account as we investigate the potential impact of planetary resonances, dark matter, and gravitational waves on Pluto and Neptune's orbits. The solar system is just one strand in a vast network of interconnected structures called the cosmic web. Throughout the cosmos, this intricate web of galaxies, dark matter, and intergalactic plasma shapes the distribution of energy and matter at the most fundamental scales. Is Pluto and Neptune's impending collision due to our solar system's location in the cosmic web? A small but considerable number of scientists have postulated that the gravitational pull of the cosmic web may affect planetary trajectories. Planetary orbits may be affected by tidal forces when the solar system passes through this enormous structure, which could cause them to move closer together or farther apart. As astronomers have found new means to investigate the universe's structure at enormous scales, the idea that the cosmic web could impact the solar system has gained support, albeit it is still a relatively new concept. Scientists intend to learn more about the cosmic web's interactions with solar and other planetary systems by charting the distribution of dark matter and galaxies. Pluto and Neptune's upcoming near collision may indicate the presence of extraterrestrial influences on our solar system. Unveiling the secret forces that regulate planetary orbits and the evolution of the solar system may be possible as our understanding of the cosmic web and its influence on the cosmos expands. We must ask ourselves some very big issues regarding our role in the cosmos if the solar system is indeed a component of a bigger linked structure. Do we not exist beyond our limited understanding as minor characters in an immeasurably grand cosmic play? Alternately, is our solar system just the surface of a much larger and more intricate relationship with the cosmos? Impending events. Pluto and Neptune's future orbits. Now that we've covered the near collision between Pluto and Neptune, the next question is, what's in store for these faraway planets? Although the immediate threat of a collision has gone, the incident has brought up significant concerns over their orbital paths and the overall stability of the solar system. After some time has passed, Pluto and Neptune may return to their stable resonance and experience no further orbital disturbances. Alternatively, the near collision may indicate that their resonance is starting to degrade, which could result in further close calls down the road. If this is so, scientists will have to keep a careful eye on their orbits to spot any dangers ahead of time. Pluto and Neptune's near collision could be a symptom of a more systemic pattern of planetary interactions that, in the long run, could cause major shifts in our solar system. We have observed that even minute shifts in planetary orbits can influence the stability of faraway moons and the courses of comets. Pluto and Neptune's orbital paths remain a mystery, but one thing is certain: even the most stable orbits can be thrown off course by invisible forces in our solar system. Our knowledge of the solar system's forming forces and future dangers will hopefully improve as we keep tracking the orbits of faraway worlds like Pluto and Neptune. The solar system is constantly changing, as demonstrated by the near collision of Pluto and Neptune. We must have our wits about us and be ready for everything that may come our way as we gaze into the future. There are many unanswered questions about the cosmos, such as the nature of dark matter, gravitational waves, and the cosmic web. Pluto and Neptune, the mysteries that keep on giving. Pluto and Neptune's improbable collision has raised many new concerns regarding the solar system's guiding forces. We now have new questions to explore, such as planetary resonances, dark matter, gravitational waves, and the cosmic web, all of which have the potential to change our view of the cosmos. Our continued investigation of Pluto, Neptune, and other faraway objects' orbits holds the promise of revealing hitherto unknown factors controlling planetary dynamics. This incident also highlights how the solar system is constantly evolving. Even though it may seem like the planets move in a straight line, the truth is actually far more complicated. From the stability of faraway moons to the courses of comets, even little alterations in planetary orbits can have far-reaching implications. We must have our wits about us and be ready for everything that may come our way as we gaze into the future. There is always something new to find out about the cosmos, whether it's about planets that were so close to colliding or about the forces that are at work. Pluto and Neptune's near collision is merely the most recent development in a continuing tale whose secrets have yet to be completely unraveled. Neil deGrasse Tyson's insights into the dynamic relationship between Pluto and Neptune reveal just how much there is still to uncover about our solar system. What are your thoughts on the cosmic dance between these two distant worlds? Do you think we're on the verge of even more groundbreaking discoveries? We'd love to hear your thoughts in the comments below. Don't forget to